Okay, so we're going to start plotting. Exciting stuff. 2 and 360. So right about there, just above. Just a smidge above, if, as they say. 8 and 200. Okay. 3 and 300. 4 and 275. Okay, there's 250, so right about there. Would be 275 more or less. 6 and 210. So maybe about there. 1 and 400. 7 and 200. 9 and 100. 5 and 220. 2 and 325. Okay. So what do you think? What let's see the trends. Would you say this is positive or negative? Negative. If you had to give this a correlation number, like we were doing yesterday, what number do you think this would be? It would be negative, I would say, because it's going downhill. Yeah, that's a good question. Would it be stronger or weaker? You know what? Close those Chromebooks. What are we doing? Close them. It's going to be stronger or weaker? What do you think? Basically, am I saying is it more than negative 0.5 or less than negative 0.5? More. Okay. Well, we can always find out, right? Let's take a minute and do that. Let's see here. What do we got? 2. Can you guys read off the numbers for me, please? 2, then 8.
3.
Oops. Okay. 3, then 4.
Then 6.
Uh-huh.
1. 7. 9. 5.
Okay. And now the minutes. 360.
200. 300. 275. 210.
I'm at 210.
400.
400.
200.
Oops, I did 40 seconds. Then after 400, it's 220.
320.
Okay. So let's see. Yeah, that is pretty strong. So we're pretty confident in that data. It's negative 9.6. Anything in the 0.8s or 0.9s are, yeah. So the connection, or at least the straightness of the line is there. Okay. So let's just write that down. R turned out to be negative 0.96. So it's negative and strong. Let's just say strong. Okay. So that means this is definitely a linear relationship. It doesn't look that way, but it is. So we're going to draw a trend line. So a trend line, sometimes we call it a line of best fit, is a prediction line. It should lie as close as possible to the middle of the data. So the data is a scatter plot, right? One way to figure it out is you try to, well, first of all, you check and see if there's any outliers. So I don't see any points that are kind of oddball points, like way down here when the rest of them are here, or way up here when the rest of them are down there. So we don't have any outlier points because we would ignore those. Okay, and then one way to do this is you try to just make like an oval, like it's not very scientific, but it actually works. You try to make an oval around your data. You see what I did? And then if you need a ruler, I'll pass them out right now. We're gonna bisect. Bisect means cut in half. Take your oval, make sure it covers the extreme point like this. So it should be like an oval shape, and it should be kind of like mine. And then we're gonna draw a line that's gonna slice it in half. So if you need a ruler, I'm gonna walk around, pass out rulers if you need them. Rulers? Okay, rulers. There you go. Rulers. Over where you phone. Rulers. 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 There you go. Rulers. There you go. Rulers. Now, for today's assignment, you don't have to go and plug in data. But what we do want to do you're going to make a line, and I like that these are kind of you want to have close to, doesn't have to be exact, but it helps if you have some points above, some points below if they're not perfectly lined up. So you just want to slice this thing in half, kind of like there. There's no exact line, especially the way we're doing it. If you have some advanced statistical software, it would do this for you, very precise, but we're going to get a pretty accurate measure. So here we go. I'm going to do this with a pen. I'm going to commit to my line. You don't have to. You can continue with a pencil. We're just going to draw our trend line. Okay? How many points are actually on this line? Maybe one. One is touching it there, and that's because they're big chunky points. There's this one for sure, right? So it's okay if none of your points are on the line. And it would still be an accurate line. This line is just kind of like our prediction. We're saying the average of our data is here. Okay? Well, we drew our trend line. Okay? And a couple of things we could do with our trend line is make some predictions. So that's what we'll do next. And your answers are probably going to be different from mine because, you know, your wiggle on your line may be a little bit different from mine. Okay? So we're going to answer these questions. So the first question we're going to ask is, how long will it take to paint a room if you have 10 people? So for me, and this will be for me, it's not necessarily for you, I'm going to go where it is 10 people. Based on this data, if I go up and hit the line, I would say maybe, I don't know, 51, 52 people for me. A little more than 50 people based on my data.
50 minutes.
Oh, I'm sorry, it would take 50 minutes. With 10 people, it would take about 50 some odd minutes. I was stuck on the people part. So it might take, I'll say a little more than 50 minutes. Try a different pen. Yeah, it would take a little more, based on my data, yes.
I know this is like not really related, but wouldn't like at some point it would start taking longer?
Yeah, in the real world, yeah. I mean, we're just doing everyone's actually working. Are you saying that people would start to just?
No, like there were like way too many people for their room.
Oh yeah.
Yeah.
They won't fit in the room.
It wouldn't fit in the room, and you know, once you get too many people, you get some that just want to just sit and be chatty, and the real world stuff kind of sinks in. But yeah, I would agree. See, there's a whole field in applied math where they do all those psychological things you're talking about. There's actual classes at universities where they take the raw data science and then they apply it with psychology with stuff that you're talking about. Yeah. So interesting. All right, let's tackle the next question. How many people will it take to paint a room in 3 hours? So this time, let's take a look at 3 hours. Okay, so 3 hours. How much is 3 hours? Yeah, how many minutes is it? 180. Right.
What's going on?
You already know, then. I'll send you the video. Okay. So, how many minutes in 3 hours? 180. So that's probably the first thing we should point out. So we want to point out that it's 180 minutes. Let's find 180 minutes over here. So somewhere about here, maybe about there. And then let's go across. Go to your line. So the important thing is go to your line. Don't go to any of the points. And see where that takes you. Now, About how many people? About 7. Yeah, you know, we can't have fractions of people, so we'll say about 7 people. Between 7 and 8.
Or someone with like an extra.
Yeah. Well, we'll hire the physically challenged. Why not? 7 people. All right. Now, here's the thing. We can use the line itself to make predictions. Much better if we have the equation. So if we have a line, are we able to write an equation for that line? What do you think? Have we been able to do that before? Yeah. So that's what we're going to do this time. We're going to come up with a trend line equation. A trend line equation is basically a linear equation that models the trend line. So say we have a scatter plot. We've made a trend line. There it is. And we want the equation of this line. So here's what we do. It says pick 2 points on the trend line. This is important, guys. The 2 points have to be on the line. You pick 2 points on the line. So that means they don't have to be actual data points. So they already picked 2 for us. I'm going to highlight them. I want you to highlight them yourself. So we already went ahead and picked these 2 points. These 2 points are probably not even actual data points. Okay? So I need that to be understood, guys. So they're just, the only reason we're picking them is because they're perfect points on the line. But they're not necessarily data points. So if you took some data and you plotted it, there's a good chance it wasn't even part of those points. It's just 2 points that are on the line. So you pick them, and you pick them because they're easy to work with. Okay? And the reason they're easy to work with is we can figure out the coordinates for those. So let's see, we've got 3, 2. And what's our other point? 7, 8. Okay, so you just pick 2 convenient points that are on the line. So we find the slope of the line and use that slope to find the equation of the line. Okay, so we got to find the slope. What method should we use? Rise over run. That's easy. Rise over run, if you can do it, is the go-to method. So let's see, we're going to rise how much? 6 over 4. Okay. So the slope is 6/4, which is 3/2. So we got a slope. Pick a point and use them to write the equation. Use your favorite method for writing a linear equation. Why? What is it? Y minus 2 equals 3/2 parentheses x minus 3. Okay. All right. So let's see here. Y minus 2 equals 3/2 x minus 3/2 times, how much is that? 4.5. Yeah, the thing is, these might give you some messier numbers, but not horrible. So in the end, you end up with y equals 3/2 x minus 6.5. Oh, yeah. Sorry, we got to subtract these. Yeah, I added when I should have subtracted. 2.5. So just so you know, another way to write this that's typical is changing these to fraction or decimals. So 3/2 would be 1.5. So either one is good. So you could do 3/2 or 1.5. Okay. So let's do one more. You guys ready?
No.
All right. Oh. The last one's on the back. So here we go. We got a graph. They already picked a couple of points for us that are on the line. We'll go with those. So one is here. And one is here. Let's figure out the coordinates for those. 4, 8. And then we have 8, 3. Okay. So we can do rise over run again or the slope formula. Rise over run. You guys like rise over run. I like it too. Okay, just saying you can use the slope formula if you like. We're going to go down, down, down. We went down 1, 2, 3, 4. We went down 5. And over. So negative 5/4. Okay. So let's use that one. Negative 5/4. And we'll pick a point. Let's use that one. I'll use 8, 3. So it's going to be y take away 3 equals negative 5/4 parentheses x minus 8. Let's distribute the negative 5/4. And what's that going to be? Plus 10. Okay. Let's get rid of the 3. So we get 13. Y equals negative 5/4 x plus 13. Or I can convert negative 5/4 into negative 1.25. X plus 13. Just converted the fraction to a decimal. Does it make sense for the y-intercept to be 13? Is that a reasonable number, plus 13? Yeah, go back to the graph.
It's still
Look at the line. It's
That's
going
an
to keep
arrow.
on going. Where's it going to hit that y-axis?
around like
At 13. So it is reasonable to have it there. Okay? All right. So now we can use these equations to predict other stuff about this line. Okay? All right. So let's talk about the assignment.